Hello and welcome. Just a quick programming note before we dive into the meat of today's video. I thought I finally had my Lambda lab up and running every Friday at 11 a.m. And then last week I couldn't do it, and this week I can't do it at 11 a.m. So Lambda lab tomorrow will be an hour earlier than usual, 10 a.m. Hope you can join me. And now on to the main event. Hello and welcome. I am back in Harry Gross's Excelopolis. Harry recently made a rash comment that he would make a physical trophy for the first person to complete all the expert challenges in the dynamic case. And I mostly tried to whiz past the expert challenges as quickly as I could to get to the divines and some other things. But let's see. Yeah, so I've done 10 out of 23, so I've got a way to go. But I'm going to see if I can knock out a few today. Let's see if Katrina will give me one. I think it's the 3 up here that are not Michael plus Julian who give expert cases. Let's see. Let's go. Okay, 15-minute challenge. An irrational decimal fraction is created by concatenating these positive integers, and we've seen the 12th digit of the fractional part is 1 if dn represents the nth digit. Find d. Okay. So, I guess first thing is, what's the biggest thing I need? That's 1 million. Okay, so let's do, I guess, sequence 1 million, I suppose. Do I have len? I don't remember any of the functions. Good, I have len, hooray. Oh, I think I still don't have sum. But anyway, that comes to like 5 million, so I don't need nearly that much. So let's do, gosh, that's loud. Let's do, I don't know, 3 by 10 to the 5. That's still over 1 million. 2. Okay, good. Do I have scan? Sorry, scan that. I don't have sum though. Ugh. Maybe I think I might be able to use. Yes, I think I can use it as an eta reduced thing even when I can't use it directly. Okay. So now, sorry, what are the values I need to get? 110, 100. Okay, so powers of 10. 110, 100. Times 10. Yeah, okay. So, let's see. The 10th digit. Yeah, so I need to look up, find the first one to get above that. So, let's start with X match. Do I have X match? I don't even know. Nope. Oh god. Do I have match? Yes, fine. Except I don't want. Ugh. Bloody. Right, no, I think I can do a range match. Match that against. Sorry, I don't need to do that. That's just one. Let's match that against this. That gives me row 9, and then an index of this by that. And I want index of this block by that. And that one should have been locked as well. Ah, except that is... Ugh, bloody hell. Oof, that's super annoying. That's not the one I want. Okay. If index that by that is equal to that, then this is what I want. Otherwise, I want that plus 1. Yes, I think that works. Lock that all the different times. Should have just made it a let. Never mind, I only have to do it 6 times, so it's no big deal. Okay. So now, I want this minus this. So, right of this by this, and that, sorry, by that plus 1, I guess, and then I want the left of that, I think. Oh god, I don't have left. Seriously? Ah! Do I have mid? Okay. So right of that by that plus 1, and then mid of that 1, 1. think that's it. So what do I do with them? Find the product. Okay, fine. I mean, I'm not super sure, but let's give it a go. 210. Wait. Okay. So that hopefully. Yep, brings me to 11. Okay. Next. The Handforth Parish Council and 11 member council for each member has a different number of votes, level of authority. A new law passes only if the yes votes add up to 52 or more. All 11 members vote yes, and they do it in a uniformly random order. What the? Huh? I mean, does this mean that it must mean they all have a number between 1 and 11, right? So sequence 11 adds up to 66. So it's probably easier to do it backward. What are the ways that you can... Uh, 14, yeah, okay. Up to or over. Okay, so... Wait, hang on. Hang on. We don't know anything about any individual member. Isn't this just 1 over 11? Apparently not. What? Oh, the probability that in the random order, Jackie Weaver's vote will bring it. Oh, sorry, multiply by 10,000. Yeah. Sorry. Nope. Still not, apparently. Yeah. I don't see that there's enough information to do it any other way. We don't know how many votes she has. Everyone's a different number. Yeah, no, there's definitely not enough information to say more than that, so I'm going to bail out of that one. Oh, I lost subtotal. What a shame. More. Lana Banana. Oh. Flits off diagonally down right from the top of a 12 by 25 rectangle, and when she reaches the border, she bounces. Okay, this is the bonus 5 from Lana on ice. How many times has she crashed into the border before? So this is kind of neat. So let's just take a simpler example for a second. Let's say we have a say we have a 3 by 4. So Lana starts here, goes here, bounces 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 back here. The main thing to notice is that for the purpose of the bounces, this is really, you can almost imagine drawing. I can actually draw it. Shapes. You can basically imagine drawing a box that goes through the middle of these. Like what you've effectively got is a height of 2. Like every, this is 3 boxes tall, but every time she goes 2 down, she bounces. Every time she goes 2 up, she bounces. And likewise for the others. So in this case, our 12 by 25 box is really going to be an 11 by 24. And so you're going to bounce vertically every 11 steps, you're going to bounce horizontally every 24 steps, and then the question is, what happens by the time you come back to the starting point, which will be the first time that you have bounced an even number on both. So you need a number that is a multiple of each of these, double of each of these, and the first time that happens, these come. seriously. Well, I saw it there for a second, 528. But anyway, these numbers are relatively prime other than the 2, so it's basically just 11 times 24 times 2. That's 528. So then the total number of bounces up to and including that is going to be that divided by these, which is 48 and 22. But then if you read the details, so a corner bounce counts as 2, but it's before she crashes back into the top left corner. So in other words, 2 of these bounces happen at the end, so we want to count before that, so it's that minus 2, which is 68. I don't know if I explained that well. I probably am too familiar with it for my own good, but anyway. Okay. Sequence is generated by a very simple rule. Term 1 is 1, term 2 is... Oh, is this the lucky say thing? 1, 1, 1, 2, 1, 1, 2... Okay. Okay. Sorry, not that. Anything followed by that. Okay. How am I going to do this? I can do mid this sequence, comma len of this 1. Yes, I can do that. Good. Then let digs be that. Then I guess num, as in what number thing are we on? Can be scan 0 digs lambda a v no, sorry, we can't do digs, but we can do sequence columns of digs. I can get rid of the ones. That'll just take a 1 as the first one and not do the first one. Then we can say lambda AV, good. So it's going to be A plus index digs V is different from index digs V minus 1. Feels slightly sacrilegious to be doing it quite like this, but I think it'll work. Oh, fuck it! Which of those many functions did I not have? Okay. What I don't even remember what I used there. Okay. So if I let digs be that and return digs, that's fine. Okay. Then num scan sequence. Oh, it's columns. I bet I don't have columns. Fine. Just go back to this. Lambda a v a plus index digs v is different from index digs v minus 1. If this works, I'll explain the madness behind it, but let's just copy. Yes, that's okay. Then num spill. What? Oh, whoops. Fine. Equals comma. Good. And then this one would be 1, 2. Then this is 1, 2, 3. Okay, good. So actually, I'd rather have this go this way and this go this way. So then I think what I want is to group by num digs. And then I want 2 functions. Oops. I want h stack. I want the number, and I want how many times it happens. Fuck, I don't have group by. Ugh! And that's deleted. I hate that it deletes everything! I'd forgotten that. It's been too long since I played this game. Oh my god. Fine. Let digs be mid this sequence len of this. 1. Nums b scan nothing sequence len of that. Oh yeah, and let me get it working again. First lambda AV A plus index, index digs V is different from index digs V minus 1. Nums. Okay. So, sorry, yeah, I want to briefly explain the dark magic that's going on here. When you omit the first argument of scan, it doesn't call the function on the first step, it just takes the first value from here. So this is taking the 1 from here as the first value. And what that means is it's never running into the situation where v is 1 and v minus 1 is a problem, because the first v that it operates on is 2. So it's kind of combining two pieces of sneakery here to make it start with 1 and not have to do this edge case computation. Anyway, okay. So do I have h stack? No, I don't. Oh, do I have group? Maybe that was the problem. Maybe h stack was the problem. Okay, good to know. So then, so annoying. Fine. So group by nums digs rows 0. Yep, that's fine. Let's get one that's a little more effusive. So what if we do if 0, 1, then digs nums. Just copy in case it deletes everything. No, that worked. Okay. So then we've got 1, 2, and 1, 1. Okay. So then we'll choose, wait, do I have choose calls? I don't know, 1, 2. Yes, we do. Okay, happy days. So then I think I can just choose calls. This, I want first the third column, then the second column, and then I just want to concat. Oh, for God's sake, I don't have concat. Are you serious? Okay. That's very frustrating. Do I have text join? I'm gonna need something. Yes, fine. Then I'll do it with text join. Text join. Choose calls of all this madness. 3 and 2. Yes! Hooray! Okay. Now what's the question? 15th. Okay, that's not so bad. So that's, what, up to 7? 8. No, wow, it breaks as soon as I go on to the next one. What? Oh, right, sorry. So then let's point this to here, and to here, and to here. Okay, so that's 8, 9, 10, 11, 12, 13, 14, 15. They're getting big, but I think that worked. Or it didn't. Wait, is that? No, that's 15. Oh god. Really? Oh, hang on, sorry, these are off by 1. Yes. So then it's this one, I guess. Whew. Okay. How we doing? Okay, we've done 3. Let's keep going. Professor Vasechkin wants to represent a positive integer as a sum of integers where each addend consists only of the digit 1. You may use plus or minus between addends. Okay. Minimum total number of okay. I don't know. 79263. I'm not sure I'm going to be doing any Excel here. Okay, so 1111. Assume 7 of these are. No, it might be more efficient to go bigger. 11111 minus 1111. That will get you to 7. Yeah, okay, you're getting kind of close now. So let's do let's do this minus, I think I should do some product because I don't have some of that. I'm gonna lock that, I'm gonna lock that. Okay, so then we want 1111. Yes. Then is it better to go from... No, I don't know. 1, 1, 1, 1, 1, 1, 1, 1. And then 1, 1, 1, 1, 1, 1, 1, 1, minus 1, minus 1, minus 1. There's got to be a way to do better than that, but that at least works. So that is 15. It's not the right answer. Okay. Okay, let's see. Suppose we instead did... Whoa, what? I did not get along for that question. Thanks. Okay, no more minifs for me. I guess there's a smarter way to do that. Alright, starting in the top left corner of a 2x2 grid and only being able to move right and down, there are exactly 6 routes. Oh yeah, I totally remember this. To get to the middle line, you have to make 20 steps, which is combin 20, 10. You have to choose 10. Sorry, what am I saying? Yeah, you have to take 20 steps. Hang on. Yeah, you take 20 steps arbitrarily, so it's 2 to the 20, I think. But no, sorry. Now I remember. So the number of ways to get to a particular spot is combin. So let's just say combin 2 by 2 is just... Hang on. So here's my 2 by 2. So I have one way to go there, one way to go there. Oh, okay, sorry. So 2 by 2 grid, it must mean like 2 by 2 centers. So you can go 1, 2, and then 1 finish. Yeah, so it's 1, 2, 1. It's the sum of the squares of those. So this is combin 2 sequence number 2. Sorry, 3, 0. Yes, okay, so then I just want to make that 20, this 21, and then some square. I think that's what I'm looking for. Boom. Okay. So where am I now? 14. 9 more to go. Alright. Oh, hang on. Now we've got 2 active menus. That is not good. How do I close? Ah. Okay. This is might break things, but okay. Alright. Oh god. We're in a 3D Excel grid. Oh lord. Sheets correspond. Okay. You can remove all points in a sequence of snaps. Wait, what? In one snap, you can remove any 2 points that have not yet been removed, and that form a perfectly valid. What? What? What on earth are you saying? Each cell represents a point in space for columns, rows, and sheets correspond to the X, Y, and Z axes, respectively. Remove all points in a sequence of snaps. In one snap, you can remove any 2 points that have not yet been removed and that form a perfectly balanced pair. But I've got to remove more than 2 points if I'm going to remove all... What? What? I'm deeply confused. Wait. What? There's some information missing here, I'm sure. Oh, here we are. Ah, okay. Now it makes more sense. Oy, okay. So let's split this by let's do Yeah, text split. Find this by S exclamation mark. That should work. Someone's at the door, so I'm gonna go check on that. I'll be right back. Okay. So, where was I? Here, it looks like there's only ever one character there. Yes? No? I don't know. Maybe? Okay, so let's just do mid this 2, 1 times 1. That ever an error? No. So then it's just code of this minus 64. Ooh, what? Oh, sorry. Close the bracket in the wrong place. Then it's mid. Mid. This 2, 2, 2, 5, just to be safe, times 1. Okay, so these are my coordinates. So, now, what? I'm still very confused by what the question is. Remove all points in a sequence size. One snap, you remove any 2 points that have not yet been removed and that form a perfectly balanced pair. 2 points form a perfectly balanced pair if no other point still remaining lies within the minimum and maximum of their coordinates along each axis. No other point still remaining. Okay, so... But what? Okay, I think I'm finally beginning to understand what's being asked now. So... Okay. So... Then what's the tiebreaker? Multiple valid sequences exist. Always choose at each snap the valid pair with the smallest first index. Break ties by the smallest second index. Okay, so each cell, columns, rows, and sheets, X, Y, and Z. Okay, so this is the column, row, and the sheet. And let's just copy value paste that stuff, and yeah, well. Turn those into numbers. Okay. So then we'll do our tiebreaker up front by just sorting. Sorry, so sort by the rows, and we'll sort by the columns. Okay. So... I guess... I really don't know. Okay, let's see if I can do something with this one. So we say by row of this lambda row. I think what I want is countifs. I want to know how many things are less than or equal to index, sorry, and index row 1. And are greater than or equal to... Oh, no. Gosh. Alright, hang on. Let xmin be the min of this and index row 1. And x max be the max of that. And let ymin be the same thing for column B, and ymax be the same thing for column B. This is tedious. And then Z min be the same thing for column C. And Z max be the same thing for column C. Okay, so now we're counting ifs this less than or equal to x max and greater than or equal to x min. Then we want b less than or equal to y max and b greater than or equal to y min. And then finally we want C less than or equal to Z max and C greater than or equal to Z min. Okay, close that, close the let, close the lambda, close the biro. And I swear to God, if there's a function here I don't have, I'm gonna cry. Okay. Oh. Yeah, it was there for a second and then gone again. I don't believe it. Oh, there's so much of this I haven't got used to. Okay, do I have countifs? Yes. Okay. Do I have min and max? God, it's just kind of tedious to not have those. Where are we? L, M. I have min A and max. Okay, let's see if I can use min A instead. Hello, min A. Oh, hang on, somebody's calling me. Be right back. Okay, nothing but distractions today. Let's see, min A, there was another one. Min A. Please work. Yes, hooray. Okay, so I think that's saying, wait, no, that should not be right. So this one, for example, this one and this one between them should contain this one, so this is not right. God. Oh, hang on. Oh, row A? No. What? Okay, that's better. So, is there any 0 here? No, there's not. Okay. So then, I'm not totally sure what to do about that. Oh, hang on. Wait, though. So this 112, that 1 probably means that's the only one, because it would count itself. Okay, so then I think 1-3 is my first snap. And then am I just going to delete those? Maybe. Alright, well I've got 4 minutes, so I gotta think fast. So let's just do that. Let's say 1-3 is my first snap. And so hang on, just tiebreaker one more time. Here with the smallest first index, break ties by the smallest second. Oh, shit, I was not meant to sort these. Oh, god damn it. Now I have to start again. Oh, that's super annoying. I'm definitely not going to have time now. I thought it meant the smallest first thing. Anyway, whatever. You know what I thought. Okay. Thanks. S with blank. Oh, no, it takes ages. It's super annoying. I might have something that works, but it's going to take forever. Okay, come on, please. Ah, it's still spinning. Annoying. Okay, text split of this by exclamation mark. So then this is going to be code of this minus 64. And it's going to be mid this 25 times 1. And then just this. Okay. So then we'll get rid of all of this. So our column is going to be this. Our row is going to be this. And our sheet number is going to be this. Go away. Okay. So now, do we have any ones here? Yes, we do. And we're solving for smallest first index, so yes. So we're going to say x match 1 against this. Oh god, I don't have x match. It's so sorry, 0 plus 1, 31. So then I think my first snap is 131. And then I want to get rid of that. Yes, 31. So I want to get rid of that. And, oh God, and then I want to get rid of this. And get rid of the last one. Okay. So now, shit, no. What am I doing? Sorry, I should have hard-coded numbers. So let's do that now. So this is 2. Then wherever we get to 31, we need to skip. Okay, so then this will be equals this, and XLOOKUP 1 in here, returning from here. Okay, so you're saying 2, 3? Really? With a good snap? They look kind of close together. Fine, sure, I guess. Okay, 2, 3, done. Get rid of that. Alright, so then get rid of 2 and 3. Do that, I'm going to copy. There's no way I will get this finished. I need something more automated. But anyway. Whatever. Ooh, why is that not contracting? Ah, there it is. Just took a second to update. Okay. So then 4, 5. Okay, really? Seems too good to be true, but okay. Okay, then 621. That's 6 gone. I'm gonna get rid of 21. And I want to get rid of the extra at the bottom. Okay, that leaves me at 7, 9, and yeah, I'm running out of time. As expected. Oh well. Alright, well, never mind. Okay, I had a crash, starting again. Let's go. I guess we'll challenge someone else this time since I've done Katrina a bunch of times, but it's all the same challenges anyway, so it doesn't really matter, but let's challenge Ashley. Okay, what do we got? Okay, so here are the people. And then here's the grid. So what is the question? Friends, sorry, it's their friends and close friends will see it, and their close friends will also share it, their friends will see it. Do not count the post. How many people would see a post by these people? Okay, so let's stick these down below. I think I might still have some weird gaps. Do I have a filter? No. Ugh. God, it's so annoying. Okay, let's do choose calls of this whole madness. And I don't have X match, but I do have match. No, I'll make array match. This against here, block. Okay, then I want to. Okay. So I want to say that is not equal to 0. And then I want to filter on that, but I can't. So let's say if that, then give me the whole array. Otherwise, give me 1 over 0. And then can I 2 call and then wrap row? Do I have wrap rows? I don't know. Let's see. Wrap rows of this by 2. Yes, I do. Okay, so then I think I can do this. So I can do 2 call. Let's just copy this in case I lose it. 2 call that 3. Yes, and then wrap rows that in, I think it's 50s. Pretty sure it's 50s. Okay. Okay. Then just here, I want to make that and that. Get rid of those. Good. Do I have VStack? No, I don't. Oof. So then, I want to make it that not equal to 0, or the name is equal to this guy's name. Yeah. Give me one more row. It does. Okay, then do I have bicall? I do have bicall, so then let's do bicall concat, I think. Minus that. Ugh, 50. No, not acceptable. There's gotta be some. Yeah, here, for example. Okay, so let's try again. Bicall. Cat. Yeah, there it is. It's equal to blank. Okay. That is not equal to blank. Okay, there we go. I don't know what I did wrong the first time, that's fine. Okay, so then. Really? Seems too optimistic. Okay, we'll try out some product of that. And then -1 for the author themselves. Is everything still pointing in the right place? Yes, seems to be. Alright. And how do we provide the answer? Semicolon, so text join. It seemed too high, but whatever. Plug it in. Nope. Okay. So Aaron. Oh, hang on. First thing first. Did I do this right? Yeah, that not equal to 0. That's right. Okay. So then get rid of all that and come back to this again. Lots of friends here. All right. Hang on, somebody's trying to call me. Okay, I had to go deal with a plumber, so I timed out on that. Oh no, I lost some square. I like some square. That's unfortunate. I did figure out while I was gone with the plumber what I had done wrong, which is I was including all of the friends as opposed to the close friends. But anyway, let's see what we got. Oh yeah, this is the one that I have. Hang on, this says 2 minutes, but this says 12. Okay, I think this one might have the timings misaligned, but anyway, okay. 3, 4, 5, 6, 7. It's 7, 7, 7. Oh, what? What? Oh, sorry, it's down here somewhere. Why is it down there? I don't know. Whatever, doesn't matter. Oh, I can't do that. God. Okay. 7, 9, 2, 6, 3. Right. 1, 1, 1. 1, 1. 1. -1. Yeah. That is 17. That's too many. So then instead of this, let's do this with one more, and then make these negative. And wait, no, sorry, too many. Okay, so now we need 1, 1, 1, 1. And could it be a negative from there? I don't think so. Wait. Oh, it's the minimum total number of ones. God damn it! That's annoying. Okay, I've got 30 seconds left. This isn't gonna work. Okay, so then 1 minus 1. Okay, no, I can't concat. Oh my god. Alright, never mind. So it's 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 4, 5, 5, 5, and 6. The answer is 45. Ah, get up there. Oh! Hooray! Okay, so I guess that means I had the answer right the first time. I just or I had the approach right the first time. I just didn't answer the right question. Anyway, permutations in ordered arrangement. Blah, blah, blah. If all the permutations are listed, I think I've done this one before, or at least maybe I tried it and failed it. I don't know. This looks familiar. If all the permutations are listed numerically or alphabetically, we call it a lexicographic order. Yes. What is the millionth lexicographic permutation of 10 digits? Okay, so fact 10. Oh, God. Okay, never mind. Equals, do I have product? I don't know. Yes. Okay. So we got 3 million. So. So I guess there are 9 combinations after that. So this is. That times 3 is too much, so we'll have gone through 2 full cycles, so not the one starting with 0, not the one starting, so the first digit is going to be 2. Then I want 9, so 8, 7, let's just move this over, 9, that's minus 1. 4, 3, 2, 1. Sorry, then point this to this. Not the easiest way I could have done this, but never mind. Okay, so then it's going to be. So we start off having a million. Then it's going to be floor math. Do I have that? I do. Right. So then it's going to be that minus that. And it's going to be equals. This divided by this. Okay, so we're going to skip 2 digits, and that's what we're going to get to. So here we're going to skip 6 digits, so it's going to go 0, 1, 3, 4, 5, 6, so the next digit is 7. Okay, then here we're going to skip 6 digits, so 0, 1, 3, 4, 5, 8, so it's 9, I think. And here we're going to skip 2 digits. Wait, hang on. Oh yeah, so I need to check for is this equals this. Yeah, that happens toward the end. I think that might have been what tripped me up the first time. Anyway, okay. So 279, then. So here we're going to complete 2 full cycles. So we complete the 0, the 1. So then it's 3. Here we complete 5 full cycles, so 0, 1, 4, 5, 6, so then it's 8. Here we complete 1 full cycle, so it's 0, and then it's 1. Here we complete 2 full cycles, so it's 0, 4, so the next one is 5. Now, here's where it gets a little trickier. Here it's at the end of the second cycle, which means we only complete 1. So we skip 0, we've already got 1, 2, 3, so it's 4. And then this is just whatever's left, which is 6, I think. So then let's text join. I think that's the answer. No, apparently it's not. Oh, bother. Okay. Let's do count diffs. This is less than that. Lock in up there. Oh, sorry, it's less than that. So then this minus this minus this. So does this mean this should have been 8? I think it might do. Sorry. Someone else at the door. This is not my day. Oh my god. Alright, where was I? So we're skipping 0, 1, or we skip 6 would get us to 6. Yeah, so that should be an 8. Whoops, damn. Okay. So then this should be 0, 1, 3. And then, yeah, this is my check. Okay, good. So then this is what, 5? No. 6, 7. The 7's already done, so 8. good. So then this is 1, yes. This is, so it's like 0, 1, 2, 3, 4, so it's 5, I think, yes. And then here, this one would be the 9, and this is, what's left? 2? No, what? Must have repeated, oh yeah, whoops, we repeated 8. Damn. Okay, so that must be 9 then. God, I'm going all over the place. Okay, so then here we skip 0, so that's 1. Skip 2, so we skip 0, 1, 2, 3 are already there, so we skip 4, and then it's 5. And then, what is left? 35, so it's 4 and 6 left. So it's 6, then 4. What? No, there are no repeats, okay. So I'll get rid of that, and then... I think that's right? I don't know. Still not right. Oh, bloody hell. So here at the end, there are just 2. So why? Bloody hell. We shouldn't have 4 left at this stage, should we? Zero, 2, or 4. That should be 3 up. I'm so confused. Oh my god. Ah! Okay, so you've got 9 factorial ones that start with 0, 9 factorial ones that start with 1. And then you're in the middle of the ones that start with 2. Okay. Then you've got ones that start with 0, 1, 2, 3, 4, 5, 6. And you're on the 7th. Yeah, oh god, I can't get this to work. What's wrong? I don't understand why this number would be 4. Yeah, like here you can be 0 or 1. There aren't 3 different possibilities. Yeah, no, here you can only be... So if there are 16, let's just do 1, 2, 3, 1, 3, and 2. 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. That's in order, yes, fine. But yeah, you should only have 6. Oh, sorry, it's because there aren't. This is not yet 10 digits. Ah, that's the problem. Okay. Sorry, you're missing a digit. So what the hell? I'm missing 0. Okay. So now, my numbers to finish with are 0, 4, and 6. And I want the index on this by this. Okay, and then I'm interested in getting the 4th one, which is 460. Okay, so then I think this is the answer, but as you can see, my confidence is not super high. Haha, phew, okay. Alright, so I've got 7 to go. I think I've seen 2 of them today and know how to do them, but just either didn't get finished or got distracted along the way. Let's try one more. I've done this one! Yeah, no, I got this one right, so I'm not doing that one again. That's the trouble, as you get down to not as many left, you are more likely to get ones you've already done. One more. Ugh, yeah, this one. I don't think that this one works. Oh, unless... Ah, yes, sorry, there it is. There it is, there it is. There are different numbers. Okay, so now it's at least meaningful. 102 and you need to get... Oh, crap. Well, one option is to say sort. Can I sort by? Do I have sort by? So many functions. I do have sort by, and do I have rand array? I do not. Don't seem to have anything rand. Oh dear, that's not good. Wait, really? I have nothing that does random numbers. Oh bother. Whatever. Okay. So I need combinations of these that will add up to between 52 and 43. I don't bloody know. Yeah, I want to randomize this, but I can't, so... what is product of sequence of 11 is too big, I know. 39 mil, yeah, way too big. Hang on, so 2 to the power of 10. Yeah, okay, hang on, this is more achievable than I thought. So let's do 10 columns. All starting with zeros, then we'll make this 1 minus that. And then we'll go to 1024 plus 2026. And then I want if this is less than this, then 1 minus this. Otherwise, this, I think. Can I use the same one for the rest? Yeah, I think that's right. Okay, so let's just check. Okay, sorry, I've got 1025 rows, that's why it's ticking back over to all zeros. So, copy value, paste. No duplicate values found. Okay, hooray. So then, I want to put Jackie Weaver out here. These are the 10 other boats. So then we're going to say, let's just 2 row of these. Ugh, I can't 2 row. Can I transpose? No. Oh, for goodness sake. Alt ESV. Can't take that away, Harry. Speak it softly, he probably can. Anyway, okay, so then it's going to be, let's do by row this times this sum. Okay. So, and then let's just do by row sum. So, my threshold is, this has to be greater than or equal to 43 and has to be less than 52. If you're at the threshold, then Jackie Weaver as the next vote will get you there. Okay, so then for each one of these, which is 0 to 10. Okay, fine. So sequence 11, starting from 0, just to be comprehensive, we'll say count ifs, or sum ifs. I want to know how many are at the threshold where the total number of votes cast so far is that. Oh Christ! I don't have sum ifs. Do I have some if? Memories of screwing around in this game. Okay, fine, whatever. We'll say sum of this times this lock equals this. Who needs array formulas? Oh, but I can't do sum either. Can I say sum product? Yes, fine. Okay. So, So for the ones where there are 3 before, so the total number of ways to arrange them is fact of 11, which is product of sequence of 11. Then the number of ways to have these 3 arranged in some order. Actually, let's just do this. Let's do let's do sequence of 11. Let's do that, and let's do this times this. So these are my factorials. So then for this, I want, there are 9 different situations, 9 different combinations of them. The number of ways that you can arrange the 3 is index this by 3. And then the number of ways that you can arrange the remaining 7 is index this block by 10 minus that 3, yes. So there are 270,000 combinations where 3 people vote first and Jackie Weaver casts the tiebreaker, then that many for 4, that many for 5, that many for 6, that many for 7. So I think the answer is some product of these divided by this. So then we want that times 10 to the 4, and we want to round that to 0 decimal places. Confidence low, but it's right. Yeah. Okay, good. That's one of the ones that I thought might be broken, but it looks like it's not broken. Okay. I think I've been at this for a while now, but I don't know because of the plumber disruption. So I'm going to check how long I've been doing this and then decide if I want to do any more. Okay, so I think the answer is I've got a little bit of editing out to do, but because I think I left recording while I was off doing things a couple times. But I think I have been about an hour, so I'm having a lot of fun. So I'm going to say one more, and then I'm definitely going to stop. Oh, it's Lana again. Hooray. Okay, this is the one with cannot eat on consecutive turns. Okay. So over here, I'm going to say if this, yeah, at the end, yes, equals this, then 1 otherwise 0. Okay. I don't make that yellow. Sorry, make the whole thing yellow is what I meant, but good. Okay. So then the number of bananas Lana can eat in the bottom row is just the number of bananas she's standing on. The number she can eat in the next row is just the larger of this and anything below. But now I think I need to be clever beyond that. Yeah, no, I think I can still do this. So we can say it's larger of, she can eat any banana that she's standing on and then get to any of these places. I need to insert an extra one. That's so annoying. Okay, hang on. Pause. Let's go screw around with this for a second. If I point these in the right place and then insert, then it'll be fine. So let's do equals, equal sign, no equal sign, and this. Okay, good. Oh god, now it's going to spin for a while because I had the audacity to find and replace. Okay, good. These are all 0 so far, but that's fine. So that's currently pointing to AM28, but now if I insert a column here, that should now, yes, good, have moved. Happy days. Okay, so then this is going to be the max of, if you're on a banana, you can eat it and then get to any of these 5 places. Sorry, plus that. Or if you're not on a banana, then you can get to any of these and just do that. I think that's adequate. I'm not 100% sure. Ooh, a lot of 2s there. That's not good. Oh, yeah, sorry. That's because this should not be pointing to the bottom row. It should be pointing to here. now it's at least moving up as we go up, which makes more sense. And I assume we're comma or semicolon delimiting these. There's a minimum of 1, that's good. Oh, no, are we looking for a total? Some of the answers, okay. So I think it's 303. Hooray! Okay. So where does that get me? I am now up to 18 out of 23. Where did I start? I think I started at 10. Okay, good. That's good progress. Maybe one more video will finish it off. Or maybe it won't, because I got stuck on at least one. But anyway, see where we get to. That's all I got for today. Thanks for watching. See you next time. Okay, I'm back again, because I can't resist. I know I'm going to get interrupted again in a couple of minutes, but let's see if I can squeeze one in. Okay, the numbers 1 to 5 are written out in words. I've 100% definitely done this one before. I'm sure I've done this one before, so I'm not going to do it. Lost I am some. Oh, what a shame. Okay, this one makes post. Okay, good. So this is my chance to fix that one. Good. So we'll take the names, and we'll take the grid. So, sorry, I remember I wanted to put the names below the grid. So first I want to find a person's close friends. So I want to say, next look up this in here, returning from all of here. Lock them both. Then Star is a close friend, I think. Legend over here? No, where's the legend? There's a legend somewhere, I swear. Oh, there it is. Star is a close friend, yes. So that equals star. Then I want if that plus this lock equals this. Which I need to put in brackets. If that, then I want the whole grid, which is this. Otherwise, 1 over 0. This is my same workaround for the lack of thingy thing, lack of filter as before, so to call that 3. Then wrap rows of that by 50. That looks much better, except this I want to be that, and then we can bycall concat. Okay, and then we want to know how many times is that not equal to blank. I'm going to sum minus minus all of that, and then subtract 1 for the odd. Oh, fucking serious. Ah, it's the sum! Oh, I don't believe it! I've lost my whole formula! Ah! Ah! Killing me. Just killing me. Okay, then that should be B and 34. I mean, you can tell that I haven't played this game for a while because I keep making that stupid mistake. So I'm going to say if that plus this lock equals this, then the grid and blank, otherwise 1 over 0. Copy all that, that's good, fine. Then we will to call that 3, and we'll wrap rows that 50. Then we'll bycall concat. I'm going to say that's not equal to blank. And we'll say sum of, and no, sorry, not sum. God, that's probably went wrong last time. Some product of n out of all that. No, I don't have n. Ugh, well, good thing I copied it that time. So just make it minus minus. Whew! Okay, so the answer is semicolon deleted. Okay, so text join. Come on. No! Oh, crap. Oh, sorry, I didn't do the minus 1. That's important. Still no. What the hell? Close friends always include you, right? Because it's symmetrical. Oh god, what a mess. Okay, so Aaron's close friends, quickly. Are Delia and Kieran. So then we get Adam, Delia, and Kieran. Or Aaron, Delia, and Kieran. And then we want any one of these, which does include Aaron. 25. Plus Aaron himself gets down to 24. Gah! Thought I had this one, but apparently I don't. Yeah, no, I got nothing. What's going on here? Alright, I guess I need to go check this one. Is there anything else I can think of? No, not really. Aaron, Delia, Kieran, yep. Let's just take it, sorry. So that, yeah, that gives 3 on exactly those 3 people. That's all good. I don't know what the hell. Let's just briefly read this again. Their friends and close friends will see it, and their close friends will share it such that their friends will also see it. Do not count the posts themselves. Yeah, it seems right. Ugh. 31. What? Oh, I wonder if this is an example difference. Maybe? Maybe? Nope. It ain't. Okay. I'm worried something is broken here, so I think I am going to pause and go check what's going on here. Be right back. Okay, just a quick cut in to explain. First, I managed to stuff up my recording starting at that point. I paused to go and look at something, and then, I don't know, I got out of sync. I, didn't unpause, and then the next time I meant to pause, I in fact unpaused and recorded the bit that I wasn't meant to be recording and didn't record the bit that I was meant to be recording. So anyway, I lost the end of this solution, and I lost a part of another one. But luckily the one that I lost a part of, I also got wrong, so I had to come back to it anyway, so whatever, no big deal. The mistake that I made here that was tripping me up was, in my mind, I thought, okay, well, whoever posts, let's say Aaron posts, Delia is a close friend of Aaron, then Aaron will definitely appear among Delia's friends, and so the author will always be one of the people who would see it, so you always have to subtract 1. The nuance that I missed there was not everyone has close friends. So, for example, Patrick, let's go Patrick up here, there we go. Patrick only has friends but no close friends, and so the people that see Patrick's post are only Patrick's 5 direct friends, which doesn't include Patrick, so you don't want to subtract off 1 in that case. So that was the wobble I missed there. I fixed that and plugged it in. And now we're back. Let's just jump in one more. Tulips. In repeated sex, pivot option transform environment. Okay. 2x5 gridded tulips. Right. So. I think that the answer to this is just 512. And it is. Am I going to try to explain that? No, I don't think I am. Okay, 20 out of 23. I've got 20 minutes before I need to leave. Don't think I'm going to get the snaps done in that time, but maybe the rest. During May Week, a row of 40 prizes are laid out, each labeled with a financial value. Okay, I've not seen this one before. 2 teams contend to take home as much money as possible. Team Badger and Hedgehog. Very smart and play game theory optimally. Each turn, a team must choose either the left or right end and can take up to 3 prizes from that end. They must take a contiguous set. For example, the team is taking the left, they must take the first item and can't take the third item without also taking the second. But as a roll, taking the money is counted up at the end of the game, assuming perfect play. How much more money will Team Badger have than Team Hedgehog? Wait, what? Oh, sorry, yeah, this is the problem I had with the voting one. Yes, there is data here. Fine. I mean, this is definitely dynamic programming, but I just don't know how. Okay, so I guess I'm interested in a from and a to. So if the range still present is from... Sorry, sequence 40. Sequence from 40. Or should we say, I don't know what we should say. Okay, so if this is from and to, so I want to say if, well, first of all, if from is greater than 2, then in A, that should not apply. Then if, sawed off. If 2 minus from is less than or equal to 2, then you just get the sum of index this lock from to index this lock 2. Otherwise, complex stuff happens. Oh, fucking stupid! Ugh. Ugh. I hate the function deletion. So if from is greater, sawed off is greater than 2, then NA, otherwise if 2 minus from less than or equal to 2, then say X, otherwise Y. Alright, that is allowed. And I guess we'll go with some product of index this lock by $5 to this. Wait, no, damn it, that's locked wrong every single time. That's super annoying. Okay, so if you can choose from 1 to 1, then you get 125. That makes sense. So now, so here, if you can choose from 1 to 3, you get 255. If you have to choose from more, then you have a choice. God, this is going to be complicated. So there are 6 different places you can send it to, which are, you can trim 1, 2, or 3 off here, in which case your opponent will get that, or you can trim 1, 2, or 3 off here, in which case your opponent will get that. Okay, so then I think it's, no, even that's not enough. Oh, bloody hell. Yeah, so it's what you get minus what they get. So it's going to be the max of 6 different possibilities, which are index this lock by this minus this. So you take the fourth thing and then they get that. Or or two things, and in that case they get F. Or you get three things, in which case they get E. That's not it, because there are three other possibilities, which is that you take the first one, it's locked by the first one, and they get this, or two other possibilities. You take the first and the second, goes to E5 plus 1, then they get H7, or you take the first, second, and third, which is this, this, and this, in which case they get H8. I think that's it. Yeah, those are values. Those are values, that's fine. Whoa, 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 whoa. Okay, so what the heck was the question? So ultimately we want to get to from 1 to 40. It looks like the answer is 215. So Team Badger goes first. Team Badger moves first, okay. So I think the answer is 215. Confidence not super high. Yes! Get in! Okay. Oh man, how am I doing on time? I'm at 21. Come on, there's two more. The snaps is one of them. I'm not gonna get the snaps, I don't think, because I've failed that too many times. Squatter delivery. Okay, I haven't seen this. You have a set of packages, each of which has its own weight. Okay. Each drone can carry any number of packages so long as they add up to at most the maximum weight. What is the minimum number of drones you would need to carry all the packages simultaneously? That's it. Okay. Okay, that's a lot of weights. Okay, so let's start with sort to call. These, and I guess I want to sort in negative order. So obviously these all require a drone. Then 99, yes, can be paired with 1. So how do I even mark that? I don't know. Then this 94 could take 3 and 3. Sure, why not? Then this 93 take 4. Sure. This 92 cannot take 9. This 90 could take 9, and this 90 could take 10. And this 89 could take 10, and this 87 could take 10. This 81 could take 15, this 80 could take 17, and this 80 could take 19, and this 78 could take 21, 77 could take 22. I mean, are we just pairing them up? Is that, it can't be as simple as that, can it? 22, yes, 76, 22, yes, 75, 23, yes, 74, 24, yes. Can we just get a jump on this? I don't know. 37, whatever, just keep going. 73, 24, yes, 71, 25 is fine, 70, 26 is fine, 65, 26. Okay, so I guess the question is, if we look at, say, all the ones that are 50 or more are going to have to be in their own drone. That's 37. And it looks like we just fit the rest in, so I think the answer is 37. Seems too easy, but yeah, it's wrong. Okay. So, none of these can be put together, so it's definitely not less than 37. It's 38. Okay, so let's do this. You can sort by these 38 sequence 38 minus 1. Okay, so oops, sorry. Yeah, oh, sorry. Yeah, fine. So okay. So there's our what? Count 75. Yes. Yes, 75 packages. All right, fine. No one. Oh, sorry. Less than or equal to is fine. Okay, so these are all true. Okay, here we get to false. Alright, so first things first, let's just copy value paste these things. Ah, damn it. Okay, so that all works. This 37 is a problem. So there's that 37, so okay, let's take both of those out for a second. And let's cut all this, move it down a couple. Then this 31 becomes a problem. Becomes a problem. And that 21 also a problem. And then let's do this plus this minus 100. Right here. Okay, so the biggest gap we have there is 4. So that's not helping hugely, honestly. Now we've got all trues. So in theory we just need to work out these, which would be another 2 drones. So I think the answer is 39, or maybe 38. Alright. So I think that's now everything except the bloody snaps that I've tried twice and failed twice. I don't think I have time to try it again before I have to go. So, oh, but now I really kind of want to be comprehensive. Alright, well, I gotta stop for now. And maybe I'll get a chance to have one more go at the snaps before I post this video. But that's all for now. Okay, I'm back for I think the last recording of this very long video. But I think I've cracked it. So, I've got 22 out of 23. The one that I'm missing is the snaps. And I figured out what I did wrong there. So I've had two goes at snaps already, but one of them I managed to not record part of because I'm a moron. And I think I'm basically going to reproduce that second go anyway because I think I had the idea right, but I put the answer in wrong. So, no, not doing tulips. Give me snaps, please. Oh, I've lost GCD. What a shame. Yes, here is snaps. Okay, so first things first, I gotta get this. Put it here. I'm just gonna find and replace S. I'm gonna find and replace. No, I'm not. I'm gonna say code of text after. Do I have text after? I think I do. I don't know. Text after that. Code of that minus 64. So that's the column number, which I think is the first coordinate. Let's just check that. Too bad, I don't think it matters, the order of the coordinates, does it? No, it doesn't. Totally irrelevant. Alright, fine. So then 1 times text before. Again, the obligatory. Do I have that function? I do. So that's the sheet, and then the row is I guess mid text after this, after the exclamation mark, 2 times 1. Okay. So that's it, and then the numbers sequence, I think there's 62 of them to start with. Yes, 31 pairs. Okay. So the magic here is to find out. Let's assume we always want to start with the first one that's available, and then we want to find another one that we can pair with that. That between them will not contain any other one. So what I'm going to do is basically do an operation on each row here to figure out if I, look at this row and this row, or say this row and this row, how many rows in total are contained between those two, and the answer should just be these two themselves. So what does that look like? I'm going to say by row. I'm going to say this. I'm going to go down a little further and just put the dot, because that'll make it shrink obligingly as I filter this. So we're going to say by row that, it's going to be lambda row. Now my memory is I don't have vstack, so I'm going to say so I want to figure out the min of each variable and the max of each variable, so I'm going to say that's going to be bycall if 1, 0, then give me row, otherwise give me this, and bycall of that min. That's the min, and likewise I want to calculate the max. So we'll say bycall max, and then I want to figure out how many rows of the whole thing are between those two. So we're going to do another by row. But this time it's going to be where this is less than or equal to mx times greater than or equal to mn. I guess we'll do by row, that's sum. So that'll give me 111 if a row is fully contained. So then I want to know how often is that equal to 3. And then I want to count how many times that happens. So we're going to say sum of minus minus. Except I can't say sum. This is what has killed me before. I write these really long formulas and forget that I can't use functions. Okay, so then we close the let, we close the lambda, we close the by row. We're just going to copy the formula in case it gets deleted, but I think that's valid. Good. So now the two things that I take out are going to be the first one here, and wherever I can first find a 1 here. So the idea is we're operating over these rows, so this one will not be included, but the row itself will always be contained. And then if there are not any others, that's your 1. So somewhere it's a good bit down on the first one. Yeah, this one here. So like the first row is 322, and then row 332, which is row 31, also is whatever it's called, perfectly balanced, meaning there's no other matches. So we're going to XLOOKUP 1 in here, and again I'll just go down far enough that it's not going to be a dynamic array returning from here, and that's that. And then we just need to filter, except usual workaround nonsense because I don't actually have filter. So first we're going to say sequence. Are we going to say sequence? No, sorry. We're going to say this, and we're going to test: is this equal to this? And that will. What? Okay, there we go. Just hadn't finished updating. Then we're going to do a by row or. So this is going to say that row I want to drop and row 31 I want to drop and everything else I want to keep. So we're going to say if that, then 1 over 0, which will give me an error. Otherwise, all of this. And Ooh, yeah, this, I don't want that to be dynamic. I want that to be A3, A64, and then a dot here as well, because then it'll shrink as we go along. So that'll give me these errors, good. And then same trick as before, I'm going to call that with 3, and then wrap rows that in 4s, and there we go. That's my shrunken down version, and now hopefully I can copy this formula, and it will, yes, it just goes to the bottom of that, which is perfect. And then I can copy these two formulas here, and then I can just take all of this and copy it a bunch of times. So, okay. So in other words, my first pair is 131, my second pair is 2, wherever that's gone, 2, 3, third pair is 4, 5, and so on. And now I just need to copy that a bunch of times. At some point this should start to shrink. Come on. How many are we down to now? Oh, we're down to 14. We're getting there. We're getting there. Okay, there we go. Good, and that's it. That's the last two put together. So then I need to wrap rows of all of this in 1, 2, 3, 5s, I think. And that'll give me, yep, these are the pairs that appear. So then what I did, I concatenated these together, and then I text joined them by a semicolon, I think is the format, and put that in, and thought I was terribly clever, and it wasn't the right answer. And then eventually did some more reading, and even though it tells you an order in which to, bring it over here I guess to be able to look at more of it, it tells you an order in which to visit the points, but where are we? Just paste this here. Ugh, what? No. Trying to show you this before I run out of time. So it tells you a tiebreaker order in which to pick the sequences, but then answer with a concatenated index of pairs sorted as if they were numbers joined by semicolons. So after scratching my head for a while, I saw that, and then I said, okay, I just need to multiply this by 1. So I went in here, did that, copy down, then sorted that, and then did something. But order of operations killed me here because it multiplied this by 1 and then concatenated it so it remained as text. Other than that, I think my second run was right, but we'll soon find out when I put these answers in. So now it's going to be text joined all of that by sort this. Moment of truth! Moment of truth! Oh, okay, and I get the factorial function. Hooray. There it is, 23 out of 23 expert. To indeed be a god. And it only took me most of the day. Anyway, that's all I got for today. Thanks for watching. See you next time. And Harry, as always, thank you for a glorious challenge.